Okay, so I would like in this lecture to introduce you to the Maven build system. This is the build system that we're going to use for this module, and it's essentially a build system that has been developed for the Java programming language. It's designed to support the compiling, testing, packaging, and deployment of Java code. It's also designed to support the management of third-party libraries, which it calls dependencies. It's specifically designed to make sure that you don't get into situations where you have two pieces of code or two bits of a project that you join together that are using different versions of the same library. So it's designed to identify those sort of incompatibilities, and it will throw errors to say, well, you can't do this because there is a conflict between the two libraries. These sort of build systems were designed really for larger scale projects. They're not designed for the sort of projects we're doing, but you really need to know them in order to be ready to use them when you get to these bigger projects. And as I show at the bottom, they're also sort of really designed to support automated test building, so automated build processes. So they're designed for this notion of continuous integration, continuous deployment, which is now prevalent throughout the IT or the software development industry. Maven can be used for developing many different types of projects. All of them will be Java projects typically, but it can support multiple different types of projects. It can support things like web application development, enterprise Java development, the development of libraries or jar files, and we can use it to create and test simple Java programs, as we're going to do today. The basic tenet of Maven is that it's based on the idea of a project, and projects in Maven are simply folders. Maven enforces a structure upon that folder in terms of what other subfolders should exist, and it requires that an XML document called a project object model file or a POM file is located in the root of that folder, and that POM file is used to configure the build process or the Maven, to configure how Maven is used within the project. I'm going to show you how to do it from the command line perspective, but integrations for Maven do exist for all major IDEs, and you should be able to. I'm going to give you some links at the end of this lecture that will allow you to go and look at and read more about how those integrations are done. In this course, all the Maven work I do will be done on the command line. It's important to note that Maven, suppose before we move on, that Maven isn't the only build system that's out there. There are many other build systems. For example, IntelliJ uses a build system called Gradle, which is an alternative to Maven. It's often a more liked alternative because Maven is an XML-based uses an XML-based project structure, whereas Gradle is more of a JSON or a YAML type structure. Gradle has a much simpler structure in terms of there's none of the XML tags involved. In fact, what's important to know from this, though, is that while I'm going to teach you about Maven, Gradle, in fact, links into Maven in many cases, and some of the things we talk about later in terms of the way that third parties are made available through Maven, Gradle can actually link into those. Maven is actually designed to work with Maven and to pull those libraries from Maven repositories. So let's go into a bit more detail. So each project in Maven has its own folder. It's the project root folder, and the common convention is that the name of that folder should reflect the name of the project. So if you're going to develop a Hello Maven project, then you should really call that project root folder Hello Maven. The project folder must contain a source folder, which is where all the source code will go, and it must contain a pom.xml, which contains the project configuration. When the project is built, Maven will generate this thing called the target folder, and all of the generated files that are created by the Maven build process will be stored within this target folder. Within the source folder, we have a main subfolder, and this contains all the main source code. It contains the Java code, which is all written from the root of which, or the default package which is contained within the Java subfolder. So source/main/Java takes you to the root folder of the Java code base. Source./main/resources takes you to a resources folder, and this is for non-Java folders that you might need within your project. So if you use anywhere in your project get resources stream, where you load, for example, a text file that's somewhere in your code base, then that text file that you load should be stored in the resources folder, and that will be when Gradle compiles things, the code, the files that are in this resources folder will be combined with the class files that are generated by the Java code and will be stored within the target folder. The test folder maintains a separate location for all your test codes, so when you run your unit tests, all those unit tests will be stored in the Java folder. And again, a resources folder is provided to allow you to specify test related resources that you might need. So if you've got some sort of let's say a text process, a natural language processing system that does some sort of analysis of natural language, and you have a test document here that you want to run, you have a test that you want to run that uses a sample document, and you're going to check that it generates the right output. Then your test case would be written in the Java class, and the resources folder would include the sample file, and the use case, the unit test would pull the source code that would pull the content from the file that's specified in the resources file. So there are many other things that get done, and I'm not giving you a full detailed overview of Maven. I'm giving you just a sort of a starting point for Maven. So if you're interested in knowing what other folders might need to exist within Maven, there is a link here to the Maven guide, which will tell you about what the other things are. There are things for integration tests, there are things for sites, there are things for defining filters that can be applied, all sorts of things. But those things are not things I'm going to talk about in this course. So the Maven build process is represented as a life cycle. Life cycles consist of phases or steps, and the idea is that when you run the Maven build system, essentially what it does is it goes through each of those phases, and in each phase something gets done to the source code and the source data, which is some sort of manipulation that ultimately at the end of when the last phase of the life cycle is released, results in deployed code. Maven has three main life cycles. It has a default life cycle, a clean life cycle, and a site life cycle. The clean life cycle essentially is used to remove content that's generated by a Maven build. The default lifecycle deals with the actual main build lifecycle, and it actually consists of 23 distinct phases. So there's a lot of steps that you can use within Maven. The site lifecycle is a special lifecycle that creates site documentation. Again, I will get you as one of the tasks to generate some of this documentation and have a look at it later on. The clean and site lifecycles must be executed explicitly with Maven, and here's an example of what we do. So here's a command line prompt, and you type in MVN for Maven. Maven must obviously be installed before you can do this, and clean. This will invoke the clean lifecycle. Maven and site will invoke the site lifecycle. It's important to note that if you run Maven site on the default Maven project, this currently does not work. It doesn't work because there is like many things, there is an error in the configuration of the current Maven release. That means that it's using outdated versions of the site. Essentially, the site lifecycle definition is using an outdated version of the plugins that are needed to create the site documentation, and as a result, Maven fails. In one of the last slides I have in this lecture today, I'm going to give you the correct configuration of the plugins that you should use, and when you use those plugins and run Maven site, you can actually generate an example website for Maven. So if you want to, so they're the clean life cycle. If you want to perform the default lifecycle, you can't just type Maven. You can, but that will just perform the default behavior. But if you want to do things in the default lifecycle, you typically have to specify phases that you want to execute. So, for example, a common phase a commonly used phase within the default lifecycle is the compile phase. This is the phase where the source code in the source main Java folder gets compiled into class files. To run that phase, you simply type in Maven compile. The package phase, which is a later phase in the Maven in the default lifecycle, which basically creates the jar file. that can be executed by calling Maven space package. Now, if you call the Maven package, when you call a particular phase, that results, and again I'll reiterate this later, that essentially calls that phase, and it goes back and it calls all of the phases up to, in order from the first phase up to and including the phase that you specified. So there's more information on the different sort of phases of life cycles you can see down here in this link at the bottom, where you've got the, again it's coming from the Apache reference this time, not the user guide. But I've pulled out here the bit of that page that relates to the default life cycle, and you can see that there's a large number of phases. Some of the key phases to notice are the compile phase. This is the phase that generates that calls the Java compiler and generates the class files. You've got a test compile phase which compiles test code, and you've got a test phase which then which runs unit tests, the unit tests specified in the source test Java folder. The package phase here does the packaging. The install phase does is an installation step, which will come to later, and the deploy phase essentially deploys your packaged product and releases it for use and releases it for external use. These things are part of part of internal configuration files that you can specify. And in fact, what you can do is, if you want, you can specify your own lifecycle phase. You can go and take this, and instead of having to follow this stage, you can create, another REMS funky new life cycle, and you can actually reconfigure it, Maven, to work with those additional life cycles as needed. So we're not going to do that sort of configuration, but if you want to do something with Maven, you need to associate behaviors with phases. By default, all of these phases have no behavior associated with them. You associate behavior with phases through plugins. Plugins are Java programs that implement one or more goals. So goals are the things that you execute. So you have a plugin is a set of behaviors. Each behavior has an associated goal, which is a name for the plugin, for the behavior, and you execute behaviors by invoking goals on plugins. Maven comes with some built-in plugins. So for example, the Maven compiler plugin has two goals: compile and test compile. Each of these goals can be bound to so you can actually call a compile phase, or you can call test compile. Each of these goals is bound to phases of the life cycle as is required. So the compile goal is bound to the compile phase. The test compile goal is bound to the test compile phase. So here we see that a single plugin can have multiple goals, and those goals can be associated with different phases. So the link between phases and plugins, between steps and between behavior that you can execute at different steps, is defined at the level of the goal, not the plugin. The plugin is a container for multiple goals. So Maven includes default bindings of goals to phases for common project types, and these are known as packages or packaging types. For each packaging type, you can define each packaging type contains a set of default mappings. A phase within packaging types. A phase within a life cycle can be mapped to 0 or more goals. It can have multiple goals with it, or it can have no goals associated with it. And not all goals defined in a plugin need to be associated with a phase. Again, there's more information on the life cycle process here, and there's more information on the default bindings of packages here. There is a default sort of first level package type, which is the jar package type, and this has the following 1, 2, 3, 4, 5, 6, 7, 8. I can't count. The following. This defines bindings of plugin goals to 8 of the 23. 8 of the 23 phases of the default lifecycle. This jar package type is the default package type, and if you don't define a package for a Maven project, this is the package that you get associated with. So here we have a process resources packet phase, and what this does is this phase copies resources defined within the main source main resources folder into a target/classes folder. This is a classes folder within the target folder of the project. The compile phase compiles the Java code within the source main Java folder into the target/classes folder. So the first two phases, essentially, one puts things from the resource folder into the classes folder. The other puts compiled the class files associated with the Java source file into the classes folder. The third phase copies test resources into a test resources folder, and the fourth phase copies compiles the Java test code into the same place as the test resources. The fifth phase runs unit tests, and it's used the Surefire test plugin. The sixth phase generates a jar file. The seventh phase does something called installing, which I'll come back to later, and the eighth phase is deploying. I can invoke any of these phases by simply typing Maven compile. Will cause compile phase to be generated, to be executed, which will cause all the phases up to and including the compile phase to be executed. So start off with process resources, so we'll call this goal, and then it will move on to compile, and it will call this goal, and then it will finish. If I call the package phase, it does process resources, compile, process test resources, test compile, test, and then package. I'm also within Maven able to directly execute a goal, and this is why not all goals are linked to phases, because sometimes you create plugins with goals that don't compile or don't fit any of the phases defined, and I'll give an example of one later on. So here, if I want to invoke the compiler directly without skipping the process resources phase, I can say Maven compiler :compile, and that will call the compiler goal. Will invoke the compiler goal on the compiler plugin, and it will only do that. It won't copy the resources, it will just compile the compiler. It will just recompile the code. So the default bindings of a package type is the minimal configuration for that type of package, and it's fully expected that you will need to extend this for the particular types of projects that you use. For example, you cannot run, and this is one of the ones I talked about, you cannot run a Java program using Maven, but there is a plugin that exists called the Codehouse exec plugin that allows you to do this. These customizations that you need to make, where you need to specify additional plugins that you want to use, are performed or are made through the pom.xml file, this project object model file. This file specifies the necessary plugins that are for the build process. Most plugins specify which phases their goals should be associated with. Sometimes you have to manually specify in the plugin that this goal is associated with with a particular phase, and not all goals are associated with a phase. So the Codehouse exec plugin provides two goals. One allows you to run a Java program in the same virtual machine as Maven is running. The other allows you to create a new process that will run the Java virtual machine. Both of those goals can be incorporated into your project, but neither goal is linked to any of the phases of the of the default lifecycle. Though, if you want to execute the code, you have to manually type in the goal in order to force it to do that. So remember, phases are different to goals. Phases can contain multiple goals. Phases are ordered. When you specify a phase, when you try to run a phase, invoke a phase, this results in the goals associated with all the phases up to and including the phase being executed. When you specify a goal, only the goal gets executed. So the second key strength of Maven is that it provides essentially a framework to manage third-party libraries. It does this through primarily a set of repositories. Things like plugins and libraries are both types of so plugins and libraries are both types of the same thing. They're both things that need to be downloaded and integrated with Maven projects in a Maven project. Plugins are integrated into the build cycle. libraries are integrated into the compilation process. They're combined with the code that we specify in the project. So collectively, plugins and libraries are known as artifacts, and artifacts are published to online repositories. These online repositories are just folders that contain HTTP or HTTP accessible folders that contain a well-defined structure. You can go and have a look at that because there's a default repository, which I always call Maven Central, that is provided with the Maven, that is provided by default with Maven. And here is the URL of it. You can click on that and go and have a look at it, and you can see the raw repository structure. There is also a repository search engine like Maven repository. There are other ones as well that you can use to go and explore what is going on, what artifacts have been created within this default Maven Central repository. You can yourself, if you want to, contribute to that repository, but there are some pretty stringent standards that you have to follow in order to get your work published in it. But it's something that you may do. If, for example, you may develop a library that you want to share with other people. You either have to create your own repository, which is not too difficult to do, or you can basically follow the necessary conventions, adhere to the necessary conventions, and you can get your repository, your plugin or your artifact published within this Maven Central repository. This is obviously the best place to get your code put, because anything in here is automatically visible to all projects. If you put things into your own repository, then you have to tell everyone how to find your repository, and that requires them making more modifications than maybe they would have in the past. I'll give an example of this later on when I talk about the structure of a POM file. I certainly do some research work where I use Maven. I create my own artifacts. I have my own custom plugins, and I publish all that stuff through a bespoke repository, which is basically a GitLab project that I'm essentially using as a Maven repository. But we can talk about that another time. So the key thing to understand about Maven is that you have all these repositories and you have these artifacts published in repositories. When you then at some point you decide in your POM file, you decide that you want to use a repository, you specify that you want to use an artifact, you specify that artifact within your POM file, and when Maven comes across that new artifact that it's not seen before, Maven searches all the known repositories for it. Now that includes the default repository repo-maven.apache.org. It also includes any repositories that you have also specified within your POM file. Once it finds and locates the artifact, it downloads it to a local cache. For Windows, it's under users/username/.m2. For Linux and Mac, it's home/username/.m2. The .m2 is a big important bit. And once it's downloaded into the cache, Maven uses the cached copy instead of the web-based copy. So it downloads from the web, it stores it locally, and it uses a local copy of the artifact whenever it runs. So the first time you run a Maven project, the first time you run Maven, you're going to see that it's going to take a while because a lot of things are going to be downloaded from the web into that M2 folder. It's downloading all the default initial configuration stuff, the basic setup, and once it's got all that stuff down into the M2 folder, the second time you run it, you'll see it be lightning fast because everything is already local. Now what Maven does include, and I talked to this before, this install phase. This install phase we talked about before. This is a special phase developed by Maven that allows you to essentially overwrite or to install a locally compiled artifact directly into your local repository. Now when Maven searches for artifacts, it searches first within your local cache, and if it doesn't find it in the local cache, only then does it go to the online repositories. So by using this install phase, you can create local versions of artifacts that are not publicly available. You can put them into your local cache and you can use them. However, if you go to a different machine, you don't get access to them because they're not published externally. They're all local copies. So you have to distribute them locally if you want to do that. But that can be good for development if you're doing that, if you're developing your own plugins. So finally, Maven artifacts are these things. These are the core sort of bit that allow this, the core idea that allow both the introduction of plugins and the introduction of third-party libraries. Maven artifacts adhere to a three-part naming convention. There's a group ID, which is an identifier for a set of related artifacts. Typically, the group ID is a inverted domain name, like we see down here. But that's not always the case. Sometimes people, for example, the JUnit developers have just got a group ID called JUnit. Okay. The artifact ID is the identifier for the particular artifact within the group. Artifact IDs are unique only in the scope of the group. So you can have multiple different artifacts with the same ID, but being in different groups, they identify different artifacts. Even more complicated, the third part of an artifact definition is a version. So you can have the same artifact developed by the same group, but a different version identifies a different artifact. So the idea here is that you can essentially build up a repository. You build up, as you work upon your library or your plugin, you can develop new versions, but the old version stays there. So anyone who has a dependency on an older version of your library, they still have access to the older version. They can still work with that older version, and then they can make the choice when they want to upgrade to the more recent versions of those libraries, as is necessary. Fully qualified artifact identifiers take the form of the group ID, the artifact ID, the version ID. And we see here is the fully qualified name of the most recent release of the Maven compiler plugin. The group ID is normally, as I say, a reversed domain name of the organization. The artifact ID is normally dash delimited. This artifact ID here is a special one. It's actually Maven dash something dash compiler. And essentially what this means is this is telling, this is a convention that's used when you create your own custom plugins. And what it will do is it pick out this as the distinguishing factor. So you can, when you have the plugin installed, you refer to this plugin by the name compiler, not Maven dash compiler dash plugin. If we go back a couple of slides, you'll see that here we're able to talk about compiler colon test compile. This bit here, this compiler, is used, or is, this part of the name. This is a special convention that Maven uses, so it allows you to have this long-winded name that tells you exactly what it is, but then you can use a shortened form of the name in just the case where it's being used as where it refers to a plugin, in order to make it easier to type. All the artifacts required for a project are specified in this pom.xml file. I suppose now is the time to have a look at that file. So the pom.xml file is an XML file. It's got project tags. Within that you have a number of different standard tags. You have the model version, which refers to the version of this project that the version of the pom.xml file we're using, and it's normally 4.0.0. We have your group ID, we have the artifact ID, we have the version, so that's your triumvirate of identifiers for the name. And then we have the packaging type. So here we're using the jar packaging. Remember, if I omitted this, if I didn't have a packaging type, this project would default to jar anyway, because jar is the default packaging type for Maven. And then we have four extra sets of tags. There's a properties tag, a repositories tag, a dependencies tag, and a build tag. So this allows the creation of properties that can be used within the rest of the project file, so you can specify configurations. The repositories tag defines repositories, the dependencies tag defines third-party libraries, and the build tags allow you to define customizations to the build process. So for example, the common use of the properties tags is to define these properties. These allow you to define the version of Java that the source code is to be considered at, and the version of Java that the compiled class files should be generated to. So this is assuming level 1.8 compliance for both the source code and the target code. Repositories are defined like this. So repositories contain a list of repository tags. The repository tag has an ID, which is just a random identifier to give it a name. It's not. It can be anything you want. It can be my dodgy Astra repo. Astra is my programming language. And then you have a URL, which is the fully qualified URL of the root folder of the repository. So this is a GitLab repository that I'm using. And that would add that repository into to be a repository that should be searched for dependencies or for plugins. Dependencies are added like this. So here's the JUnit dependency. So here we say that we're using a JUnit library. So this adds this is a JUnit jar file, and we're saying that they've used the group is JUnit, the artifact's called JUnit, and the version is 4.12, and that will cause when Maven is executed, that will cause the jar file associated with this particular artifact identifier to be downloaded into the M2 cache and to be integrated into your code. Finally, the build process is customized through the plugins, so you define your plugins, and here this defines my Astra Maven plugin, which is one I've developed. This is another form of that convention. The other one was Maven something XXX or something plugin. This is Astra-Maven-plugin, and this then would incorporate that, and that plugin includes automatic bindings to different phases of the build of the default lifecycle. So some useful plugins you might consider in the future. This is the Codehouse plugin. This allows you to run Java code online. So this allows you to run Java code through Maven. You notice here you have to specify what is the main class you want to run. This here is a set of updated plugin definitions for that will allow the Maven site the site lifecycle to be used with Maven. If you don't install these plugins into your prom file, then when you type in Maven space site, you'll get an error. If you put these in, the error will go away. So again, there are lots of introductory courses and videos you can go and look at. There's a Udemy course that's free. There's some YouTube videos that describe it. There's some videos about how to use Maven with IntelliJ and Eclipse. You can also download it from the command line. There's a video on how to do it for Windows, for Mac, and for Linux. It's sudo apt install Maven. Okay, so that's the end of this first lecture on Maven.